This is the pre-AP Unit 6 essential skill, the acid-base equilibrium. And there's just one. It's pretty actually easy. You guys have seen a lot of equilibrium before, just adding one more element to this. The first thing you should know is that this essential skill, when doing this essential skill, equilibrium, it's only for weak acid or bases. This is not done with strong acid or bases. We're going to make an ice table and calculate what the concentration of the H plus or the OH minus is. When you have a strong acid or base, it's assumed it all goes to completion. So the concentration of the H plus or the OH minus is the same as the concentration as the acid or base. But with the weak acid or base, it does not dissociate completely. And so as you can see in the picture right here, the strong is all dissociated, but the weak is not. And so what we're trying to do is figure out, okay, if in the strong it's all dissociated, so it's the same as however many you had to begin with. Here, we don't know. It depends on what the equilibrium constant is. Because we will give you the equilibrium constant. You're not trying to find that equilibrium constant. You're just trying to find the H plus or the OH minus. So as an example here, I have the weak being acetic acid, HC2H3O2, and its Ka is 1.8 times 10 to the negative fifth, which means that it really favors the reactant side. A lot more molecules of reactant than there are other products, whereas for HCl, the equilibrium constant Ka is 1 times 10 to the sixth. So we're talking a million. And so they're pretty much all on the product side. So if we had a problem that says calculate the OH minus concentration of a 0.5 molar solution of methylamine, the CH3NH2, and we give it a Kb, it's equal to 4.4 times 10 to the negative fourth. Well, this could seem overwhelming, but let's break it down what you already know. Methylamine is a base because, well, we're asking you to find the OH minus. So that's the first thing you should realize. We're not going to ask you to find the OH minus of an acid or the H plus of a base. Very straightforward like that. So you know it's a base. All dissociation equations involve water, so you're going to have to write it out in a dissociation equation. And it's not one of the strong bases. It's a weak base, you know, because we're asking you in the first place. It gives you a Kb that's really small. But, if you're going to AP Chem, you're going to have to memorize the strong acids and bases. There's only about 6 of each. It's pretty easy, so everything else is weak. Anyways, so it's going to stay mostly in its molecular form. So how do we find the OH minus? Well, we're going to use an ICE table. And ICE stands for initial, change, and at equilibrium. We know that initial, it said that we had a 0.50 molar concentration of the CH3NH2. And so plus water dissociates into the methylamine plus the hydroxide. Water as a liquid, you guys should be all very familiar with that now. The equilibrium constant does not involve pure solids or liquids. So that's all gone. We're not going to do any concentrations for that because it plays no part in calculations involving K. Then there's a change. You lose some amount of this base and you gain some amount of the methylamine and the hydroxide. You know it's not going to be very much because we said it's weak, and so it doesn't lose very much. So it's initial concentration of 0.50 minus the X, right? That will tell you how much you have remaining at equilibrium of the methylamine, and then the X also represents, because if you lost that amount, you gain that exact amount of the methylamine and the hydroxide. So when you're going to plug this into your equilibrium, so up here, this is an equilibrium equation, a dissociation equation. Right here is the equilibrium constant, equilibrium expression. So dissociation equation, equilibrium expression. So you have the products over the reactant. Again, water's not in there. And this is where it can get tricky. And we'll probably give this to you every time, but this minus X, we told you this is a small amount, right? This is really small. Well, X, most of the time, it's going to be negligible. You can pretty much ignore it. So that means you can remove it. So where we have 0.50 minus X is basically 0.50. If you start taking into consideration sig figs, The number, it will not change the actual number. But there are some rules that you can use. One is that the concentration of the acid or base, the weak acid or base in question, so the concentration divided by, so the concentration of the weak acid divided by its Ka, or the concentration of the weak base divided by its Kb, if it's greater than 1,000, you can ignore X. In that equation, if you understand what I'm saying here, for this right here, if this right here is greater than 1,000, you can ignore this X. Only that one. You have to keep these two, okay? And if we did the calculation, 0.50 divided by 4.4 times 10 to the negative fourth is equal to 1,136. There's also something called the 5% rule. When you find X, it ends up being less than 5% of the original concentration, then you can ignore it. Or sometimes what I'll say is if Ka is less than 1 times 10 to the negative fourth, you can also, or let's just call it K. If K is less than 1 times 10 to the negative fourth, you can also ignore X. Now this one, it was 4.4 times 10 to the negative fourth, which means that it was larger, so you couldn't use this hard and fast rule, so you'd have one of these other math calculations that could help you. Suffice it to say, you start with 0.50. You're going to continue to use 0.50 because the X is negligible. So when you plug in all those values, you basically get Kb is equal to X times X over 0.50. So 4.4 times 10 to the negative fourth is equal to X squared over 0.50. So we multiply both sides by 0.50, and we're going to end up square rooting both sides. So X is equal to the square root of 2.2 times 10 to the negative fourth, which is 1.48 times 10 to the negative second. For the sig figs we've been using, it ends up being 1.5 times 10 to the negative 2 molar. This is your answer, okay? And if you want to know if it was less than 5%, 1.5 times 10 to the negative 2 divided by 0.5, which was the original concentration, times 100 gives you 3%. So that just confirms what we had. So just to go back for a second, there are several steps you're going to need to do when solving this equation. And we'll highlight those in orange, let's say. So here's the equation up here, right? So, or the problem. Given the problem, you're going to have to do several things. One, you're going to have to write this equation right here. Okay, it's this dissociation equation. And you'll notice that base and acid, because the water ends up giving up an H to the methylamine. So you have to pay attention that you're going to do it with water. If it's a base, the water becomes OH minus. If it's a weak acid, then H2O is going to go to H3O plus. Then that's the first thing. So number one, you're going to do that. Number two, you're going to have to build an ice table. Okay? This ice table right here, or something similar, with water and crossed out the water part. Okay? You're going to have to do all of that. Then, the third thing you're going to have to do is write this equilibrium expression. Okay? Not any numbers, just the variables. Okay? And water is not included in this. Don't forget that. No water. Okay? Now, you need to say something about how X is negligible. You can use the 5% rule, you can use the greater than 1,000 rule, or you can say, depending on the situation, if Ka is less, or K is less than 1 times 10 to the negative fourth. So you can do any of those as your number 4 thing to do. Okay? But you need to make mention of it. You can't just make it disappear without saying anything. And then finally, the fifth thing you have to do is the calculation where you have to plug in the numbers. Now, I would say that a lot of it is going to seem easy, and like you're going to be like, oh, it's really easy, I can just jump to the end and plug it in. And yes, you're right. For right now, it's really easy, but you need to get this down because once you get into AP, it gets much harder, and so we need to establish the good habits now. Okay? And then if you're really good, you could take this and you could get the pH from that if you're really good. So Okay, so that is your essential skill. That's it. Your only essential skill for this unit. Make sure you read the notes. That should hopefully explain it, and then do some work in the worksheet. And this should be plugged into a Zaption video, so there should be some questions involved with this too. All right, let me know if you have any questions. Thanks. Bye.